Hi, welcome to our recording of project number 3 for JHU's RTOS class. In this project, what we have accomplished is an optical tachometer that uses an infrared LED and an infrared receiver to measure essentially the RPMs of an object such as a propeller between two LEDs. We can begin by going through the code. At the top, we define a set of variables, RPS, which is the revolutions per second, RPM, which is the revolutions per minute of the hypothetical propeller between our two diodes, prev millis, which is the previous recorded interrupt time um, in milliseconds, the interval, which is actually currently unused and is more there for debugging, current time, which is the current time recorded in microseconds, prev time, which is previous time recorded in microseconds, diff time, which is the difference between the current time and prev time, and two variables for the IR receiver, which is equal to 2 to indicate pin number 2, and triggered, which is used by the interrupt to flag that a new recording has essentially been triggered. Beginning with the setup function, we initialize the serial uh, console. We set the pin mode for the IR receiver to be an output type, and we set it to send a high signal of 5 volts. After that, we initialize our analog comparator pin to record a falling edge like recording and have that trigger an interrupt. And we begin the serial communications and print out the header. Within our ISR, we keep it simple and simply set the triggered variable to true. This then follows into the loop where we check to see if that triggered variable is true. If it's true, we disable interrupts temporarily, calculate the RPM, change the triggered variable back to false, and re-enable interrupts. Then we go to inside the RPM function where we calculate the RPM values and print it out to the serial bus. After we're done with that, we change prev time to equal current time to get ready for the next iteration of the loop. Now I will demonstrate the recordings for our project. So I have a pen here, which I'll use in place of a propeller. And if I move it over the sensors, we can see that it gathers recordings. And you can see it there in the double digits because I'm slowly moving it. And now that we have a few of those, I'll move it a little bit faster. And we can see the recordings are much faster, indicating that our project is working as expected. That's it for this demo. Thanks for viewing.